sorry, I got distracted. So now we're looking at simplifying compound fractions. Compound fractions have fractions over fractions. Now, I've got the feeling that Brodie's already saying, Miss, this is stupid, but we're going to do it. So I'm just going to run through the first example, and I'm going to do it really slowly, okay? And I do it a slightly different way from the book. So we've got a half minus a third over a quarter plus 1/6. Now you may think that you can just chuck this in your calculator. That's not going to help you when we get to questions that involve things like t. What we want to do first is make these, do the fractions on each line. So a half minus a third. We're going to try and simplify that. So half minus a third, well that's we're going to aim for 6 on both of those, times 3, times 2, so we're going to end up 3 minus 2 over 6, which is 1 over 6. Now let's look at the bottom. We've got a quarter plus a 6. We're going to aim for 12 on the bottom because that's the lowest common denominator. So let's have a look. We're going to times this one by 3. And that gives us, oh, this should have been 2. Why didn't you help me? Why didn't you fix me up? 2. I was wondering why they came out the same. So we've got 3 plus 2 over 12. 3 plus 2 is 5 over 12. Now, we still need to deal with this last thing. So let's now have a look at this. This is the same as 1 on 6 divided by 5 on 12ths, yeah? 5/12ths, not 5 on 12ths. Because a fraction is just division. It's the top one divided by the bottom one. I know how to deal with this because I keep flip change. 1 on 6 times 12 on 5. And now I can just cancel diagonally 2 and 1. Oh, my maths. 1 times 2 is 2, 1 times 5 is 5. So it just comes out as 2/5. So yes, these kinds of questions are kind of really tricky, they're intricate, but they're doable. Let's have a look at one without actual numbers. So we've got 1 on t plus 1 over 1 on t minus 1. So that 1 on t plus 1 is the same as 1 on t plus 1 on 1. I'm going to aim for t on the bottom. I don't need to do anything to that one that already has t on the bottom. But the 1 on 1, I'm going to multiply by t on t. So I've got 1 on t plus t on t, which gives me 1 plus t on t. Over. 1 on t take 1. We're going to deal with this really similarly. We've got 1 on t minus 1 on 1, and we're going to times that by t on t, which then gives us 1 on t minus t on t, so we get 1 minus t on t. Now let's have a closer look at this one. I'm going to actually write this as a divides now. So we've got 1 plus t on t divided by 1 minus t on t. You may have already started to think, well, aren't those t's going to cancel out? Because when you change that to a times, they're going to be diagonal. You're correct. And they like asking questions like this in advanced. 1 plus t on t times t on 1 take t. We're going to end up with 1 plus t on 1 take t. And that's it. We can't stop. We can't do anything more now. We can't factorise either the top or the bottom because there's no squares or anything in it. And they're not the same thing, so we can't cancel them out. That's it. That's compound fractions. Just give yourself lots of room, pretty much. Yeah. Give yourself lots of room.